Welcome. Continue the study of monotony. In this video, we'll see the solution of one example of finding the monotony of a function which help us to find the extreme values of a function. So consider the example number 1. f of x is equal to x cubed minus 3x plus 1. And they asked to find monotony and extreme values of this same function. So as from the previous video, we saw that there are three propositions. The first of all, f dash of x should be equal to 0. And this will give us critical points. And then the next one was f dash of x should be greater or equal to 0. This one if the function is increasing. And the last one if the function is decreasing. So now we have our function f of x cubed minus 3x plus 1. So the first thing to do is to apply this proposition. So what we do is f of x is equal to x cubed minus 3x plus 1. So we find the derivative of this function. This is just power rule. So we have 3x squared minus 3. Now we apply the critical points proposition. So this 3x squared minus 3 should be equal to 0. So 3x is equal to this 3 comes to the other side, becomes 3. This is a square. So as this 3 comes to the other side, becomes 1. So our x will be plus or minus 1. So we have our x equals to 1 and x equals to minus 1. So this we can call as x1 and this we can call as x2. So consider that we have this line here. It's a graduated line. It goes to plus infinity and started on minus infinity. So if you consider that this point is 0, you can say that this would be minus 1 and then we can consider this as 1, which are the critical points. So now we have this table, and in order for us to find the behavior of the function, we have to fill this table. So in this column we have the values of x, and then in this will be filled with the values of x in the intervals of x in the row, and here we have this row to be filled with the values derivative of this function, which we will see, and then this one is the row that's going to tell us whether the function is increasing or decreasing. So we have the values of x. The values of x are here. So our function was coming good this way, but when it reaches this point x equal to minus 1, something changes. This is a critical point, so we stop here in this critical point, and then this function again continues from 1 and goes to the infinity. So we have this range, which is a space between the two critical points. So we have this interval, the space between the critical points, and we have this one from the second critical point to the plus infinity, considering this as being the values of x. So what we have, we can represent now as from minus infinity to minus 1, which is this interval, and then the function will stay in 1 minus 1, which is this point where it's a critical point, and then this function will be from minus 1 to 1, which is the second interval, this one, and then it will stay on 1, which is our critical point, and then this function will be from 1 till plus infinity. So this is the last interval. So we have represented these intervals here. So now what we have to do is to check whether the function is positive or negative within these intervals. So how do we find that? We have f dash of x, so we have to take the function f dash of x, which is the differentiated function, and then we have to replace in that function any value of x between this range minus infinity to minus 1. So taking this as the function, I can replace a value that is in this interval can be from minus infinity to minus 1. So let me take, for example, I'm taking minus 2. So if I choose minus 2 here, in this function I have f of x, f dash of x is equal to 3 into minus 2, I'm replacing the place of x with the value that I've chosen within the interval, minus 3. So our solution, what we have is 3 into 4 minus 3. This is equal to, this is 12 minus 3 is 9. So 9 is a positive value, so this function within this range is positive. And then the next step, I have the critical point. So what is the value of this function, the derivative one, when we are in the critical point, which is here? So I'll take again the same function, f dash of x is equal to 3 into minus 1, I'm replacing the place of x with the value of the critical point, minus 3. So this is 3 into 1 minus 3. This is 0. So the function is 0 at this critical point. Again, I have this range from minus 1 to 1, and from minus 1 to 1 I can just choose 0. So if I choose 0 in the differentiated function, so what I will have is, this means this was of f of minus 2, this was of minus 1, this is of 0, f dash of 0. So if I choose 0, I'm having 3 into 0 square minus 3, and the solution of this is minus 3, and minus 3 is negative. So this function is negative within this interval. And again, I have this critical point 1. If I replace this function, the derivative, and then I put 1 in the place of x, I'll just use this one. So I will have 3 into 1 square. So 3 into 1 is 3, minus 3 is 0. So this function will again be 0 in this point. And the last interval is f dash of, I can choose any value here. I will choose 2, that you can choose 5 or any other value. So f dash of 2 will be equal to 3 into 2 square minus 3. So this will be, this is 4 and this is 12. Then we have 12 minus 3 becomes 9, and 9 is a positive value. So as we have finished now solving for this row, now we come to this row, and it's time for us to apply one of these propositions. So the first proposition, f dash of x whose equal or greater than 0, then the function is increasing. Yes, this function, the derivative of this function at this interval was positive, and any number that is positive means that this number is greater than 0. So means that this condition is fulfilled, then our function is increasing. Why it's increasing? Because f dash of x at that particular interval was indeed greater than 0, which was 9. Then we come to the next point, it's negative, which means that the derivative of this function at this interval was negative, and when it's negative means that f dash is less than 0, so it was decreasing. And then again it was positive, so it means the function was increasing. So the second and third proposition help us to, using these conditions of the function, whether it was increasing or decreasing, know now whether the function was indeed increasing or decreasing. This tells us the function is positive or negative, its derivative, and according to that we find if the function is increasing or decreasing. So we know that the function was increasing here, the function was decreasing here, and the function was increasing again here. Okay, but this function was increasing till which point? What was the maximum value of this function after it was increasing, and then it stopped increasing to decrease? And likewise, what was the lowest point that the function has reached and then it started to increase again? So to answer that, we have to fill these blanks here, which are the extreme values. And to fill the extreme values, what we do, we use the original function f of x, but now in place of x we replace by the value of the critical points. So we have f of minus 1 is equal to minus 1 cube, because we're replacing x with minus 1, into 3 into minus 1 plus 1. So this gives us minus 1 plus 3 plus 1, and these we simplify, and then we have 3, which means that when the critical, in this point, the critical point minus 1, the value of the function is 3, and after this 3 the function stops increasing and it decreases. So our 3 is our maximum value of this function. So the maximum value of the function will occur at the point x equals to -1. Here we are going to have the maximum value of the function, and then minimum value of the function. In the same thing, we use the same function f of 1, because we're in the critical point, which is 1, is equal to 1 cube minus 3 into 1 plus 1. So this is equal to 1 minus 3 plus 1, so this is equal to -1. So this was our maximum, so this is our minimum at this critical point x equals to 1. So the minimum value of this function is -1. So the interpretation is that the function within this interval, from -infinity to -1, the function increases until it reaches a point f of x is equal to 3 or y is equal to 3. After that the function decreases, and after the function decreases till a point y is equal to -3, and then the function increases. And this is the graphical representation of our function. So as you can see, indeed the function, it reaches its maximum point here and its minimum point here.